I'm Jamie Kitchen, Training Manager with Danfoss. In this video, we're going to take a look at the basic circuitry and wiring overview for the Danfoss Optyma controller. For convenience, here we have an enlarged view of the controller connections as well as the schematic, just so we can see a little bit better when I am explaining what each of these do. In this image, we have highlighted where the power line of neutral is connected to the controller. So you can see that we have the connections along the top, and each of these connections has a common, normally open, and normally closed, as well as an identification of what they actually are. If we drop down here, you can see a little bit better how these are all separate inside the controller. So to start with, you have your power to the controller, L and N. This powers the controller and only the controller. In other words, we call these dry contacts here. You will need to bring separate power into the common of each of these contacts and then select which one, normally open or normally closed, that you want to use based on the required function. So each one of these will have their own requirement for power, with the exception at the far end here, you can see NTC S1, S2. This refers to the two sensors that can be used for not only space temperature control, but also for temperature terminated, temperature initiated defrost. And we'll get into that a little bit more in a second. So let's start with the first contact, auxiliary. This is exactly what it says. It's an auxiliary contact that, based on the programming parameter that you select, can be used to either start the compressor directly, or more common, is used to power just about anything that you want to turn off and on, along with the call for cooling. So if you want something to be on when the compressor is running, select the same normally open contact. If you want something to turn off when the compressor runs, like a crankcase heater, then you can select the opposite contact, say normally closed. But that is, anything is up to you what you want to put on there. Next, we have the aptly named cool contact. Most of the time, this is used to power the liquid line solenoid valve. In refrigeration, when the thermostat calls for cooling, it will energize the liquid line solenoid valve, which opens, provides refrigerant to the metering device, and allows refrigerant feed to the evaporator. When the thermostat is satisfied, it will kill power to that solenoid valve, which will close and stop feeding refrigerant to the evaporator, which is then pumped down by the compressor, and the low pressure control then will open up and stop the compressor. And of course, all of that reverses once the call for cooling is initiated. Next, we have fan. This is actually the evaporator fans. So the evaporator fans generally run when the compressor is on, and depending on the type of defrost you have, can either be on or off during defrost, and when the system is not calling for cooling. So in off-cycle defrost, we generally leave the fans running when the system is off because we use the space air to defrost the evaporator during the off-cycle. If you have electric or hot gas defrost, then you will generally want the fans off during defrost, and maybe even off for a minute or two after the compressor starts, just so that you can allow for the refrigerant high pressure to be quickly drawn out of the evaporator. Also, you may delay the fan or the compressor starting for a minute after defrost to allow some of that condensate to drain off as well. Speaking of defrost, that's next on the list here. You have your common coming in, normally open, normally closed. This powers your defrost, your electric or hot gas defrost. And again, that can be based on time or temperature as you choose. Next, we have a second set of auxiliary contacts. And these contacts, once again, can be used to power whatever loads you happen to choose, whether it's a a door left open alarm, a temperature alarm, lighting, you name it, these can be powered by these contacts. You have a digital signal input, which could be something like a low pressure control. It could be a high temperature, cut in, cut out, whatever you want it to be. Something can be put in there. That would be a digital on-off input. Next, as we mentioned already, you have your sensor input. One sensor is used for off-cycle defrost because you do not need a second sensor to measure your evaporator temperature. You just allow the space air to defrost it during the time that it is not operating. If you do select a second or a electric or hot gas defrost, and you want to have temperature termination or temperature initiated, you will need to use that S2. Now, keep in mind, it's important, that ground you see here is common between S1 and S2. So make sure you share that common, that ground rather, between those two sensors and don't move them over to another set of contacts. Finally, you have your communication connection here. RS485 is the standard, and this can be used to communicate with an outside controller of whatever type you happen to have. Thank you for watching our video. For more information on the Danfoss Optyma Controller, please visit the link in the description below.